Are they? Minority? Current? Carriers. And very simple for you to verify. P-type semiconductor contribute to what? Holes. P-type semiconductor contributes to what? Holes. N-type semiconductor contributes to what? Electrons. So holes are many than what? Simple logic. There's no need for you to claim this stuff. Simple logic, which you have to understand once and you keep in your mind. Then, the schematic symbol of PNP bipolar junction transistor is this one. So the fundamental is this one. Stop writing, stop drawing. And stop making stories. Greet your neighbor. Good evening. Again. Greet with a smile. Good evening. Good evening, technician. Is your neighbor happy? Okay, listen. Listen and watch. This is P type semiconductor. This is N type semiconductor. And this is P type of semiconductor. Listen. Listen and watch. Filippo now is writing. This one is base terminal. And this one is emitter terminal. And this one is collector terminal. Okay? Okay? Listen, keep listening and watch. Then, for the P-type semiconductor, the current enters through the emitter. And then be distributed to or being distributed at these junctions towards the base and towards the collector. Towards the collector. So the emitter will supply current. Okay? Okay? And these currents, once it reaches at this junction, it will be divided. Some of currents will flow in this direction, and some of currents will flow in this direction. That's why that we still have base current, and here we have emitter current, and here we have what? Collector current. Okay? So the mathematical equation of total current or emitter current still hold. Base current plus collector current. The only difference that in case of the NPN transistor, currents enter through the collector and base. Then leave the transistor through the emitter. Tell your neighbor, stop writing, stop drawing. Listen and watch. In case of PNP transistor, the currents enter through the transistor by using or enter through the transistor through the emitter terminal, right? And then leaves the transistor through the base and through the collector. So this mathematical equation seems holding for this type of semiconductor, and since it still holds in this type of bipolar junction transistor. Are we together? Are we together? Okay. So this is figure what, Priscilla? Priscilla, this is figure number 16. Schematic symbol of what? Of P and P bipolar junction transistor. The physical appearance of either. Listen, let me address about the physical appearance. Say physical appearance. The physical transistors are manufactured. First of all, in this world we have so many types of transistors. So many. So for instance, in case we can have, you may find that maybe more than 20 types of NPN transistors. And those are still few. We have through holes NPN bipolar junction transistor, and also we have surface mounting NPN bipolar junction transistor. We have also through holes PNP bipolar junction transistor, and also we have what is surface mounting device PNP bipolar junction transistor. So we have various types of transistors in simple. Whether it's bipolar junction transistor, whether it's unipolar. When you go for the unipolar, we have so many, more than 100 types of 40 unipolar junction transistor, because those are the fastest switching semiconductor device. Nyamegi is okay. So that's the case. So the physical appearance, the simplest or the common form. There's a different physical appearance of the 40 of transistor. First of all, most of the transistors are 3 terminals. So you can find that this is the appearance of 40 of the NPN or PNP transistor. Class, I say it's operating and look. And also you should never claim that always the middle, this terminal is base. That is not true. This terminal can be either base or collector or emitter. How can you know that which terminal is collector or emitter or base? You have to use the data sheet or you have to use the multimeter, where we have a device that we call the bipolar, bipolar junction transistor tester. Are we together? You might find some types some of the transistors which are in this shape. So there's a different physical appearance of 40 of transistor. Okay? If you have any question about bipolar junction transistor in relation to the schematic key symbol, please ask me. I just cleaned this physical appearance because I know you can draw yourself. Do you have any question about schematic symbol of bipolar junction transistor? Why the equation of NPN and NPR? Why the? I have explained. Because in this PNP, this is total current. So total current is supplied through the transistor. And then we have this route and this route. So it's only meter DC currents that will be divided and flow outside of the transistor through the base terminal and the collector terminal. In case of NPN, it's vice versa. The current is supplied through into the transistor by using emitter and base terminal, and then it leaves outside the transistor by using emitter terminal. So that's why we say that this mathematical equation holds for both types of 40 bipolar junction transistor. Okay? Okay? Are we together? Yeah. So that's the response of that question. Another question? Oman? My friend there who has been counting the Mwendokasi? Backbencher? No question. So you'll be ready to answer the questions I will give you in a test. Or it depends. When I give you a chance to ask me a question, you don't ask a question. When I ask you an exam, you say questions are tough. Okay. So if that's the case now, let us go to the second type of 40 of transistor. which is unipolar junction. Unipolar junction transistor. Xenodiode is concentrating with something else. Xenodiode. Feel it? You have to be happy when you've been called with the name of electronics, eh? Feel the effective. Feel the effective transistor. So in short, we call it effect. Say field effect, say unipolar junction transistor. Say unipolar junction transistor. Again, say unipolar junction transistor. Again, speak loudly. Again.
Unipolar junction transistor.
Again, is what? Say field effect transistor. Please pronounce these words because when you pronounce them, you keep in your mind. Say field effect transistor. Or call it effect. Say effect. That will be what? You are third born or fourth born? Second. First born. So in short, we call it faith. So the fundamental, I know that in ordinary level physics, we don't teach you about the field effect transistor, and we don't introduce you this concept. So I have prepared some key points that can give you the idea of field effect transistor. Then we'll go for the schematic symbol. Okay? So the fundamental question number 4. So what is field effective transistor? What is the meaning of faith? So you may define the meaning of this transistor by just referring the name. We say the uni or di means what? Means bi or di means what? Then uni or mono means what? So bipolar junction transistor, we say it's a type of the transistor which conducts electricity by using electrons and what? Holes, carriers. So for unipolar junction transistor, you expect that this one is a type of transistor which can conduct electricity by using only one current. By using only one current, simple like that. But the stuff are not simple the way you think. But just to introduce in your mind in a simple language, you can have such kind of a definition. Okay? So you say that unipolar or field effect transistor is the type of transistor that uses or that conducts electricity by using only one current carrier, either electrons, or false. So unipolar junction transistor, it's a type of transistor that conducts electricity by using only one current carrier. Is electrons or what? Is electrons or what? Holes. So that's the first difference between bipolar junction transistor and what? Field effective? Field effective what? Transistor. Ask your neighbor, do you like electronics engineering or no? Or in other words, field effect transistor is the type of transistor that uses electric field to control the flow of electric current in a semiconductor. Field effect transistor is the type of transistor that uses electric fields to control the flow of electric current in a semiconductor device or in a semiconductor material. So that's why we call it a field effective transistor. Uses what? Electric. Do you remember electric field? Ask your neighbor, do you remember electric field? If he or she say yes, ask him or her to draw the electric field that you remember. Draw them. Draw the electric field for your neighbor. Somebody is drawing what? Somebody is drawing valence shell of electron, of an atom. Hey. Okay, anyway, because you're a beginner in this business, when we say electric field, we expect it to have a positive charge, or we expect it to have a negative charge. These are the only two sources of electric field. So the positive charge, this one has the electric fields which are flowing outwards. The negative charge receives the electric field or has the electric fields towards itself. Okay? 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 So when you say electric field, for instance, if you do remember, in case of the capacitor, this we call it positive plate capacitor, and this is negative plate capacitor. So this is positive plate capacitor, negative plate capacitor. We used to draw, when we've been teaching you, introducing you the concepts of the capacitor in static electricity, we used to draw straight lines like this. But remember that in most cases, electric field lines are not straight lines, they are curved. But in simple representation, these are what we call them electric what? Electric what class? Electric wave. Electric field. So this is in case of the capacitor, positive place of the capacitor, negative place of what? The capacitor. So you see that the positive plate is the source of electric field, and the negative place is the receiver of electric field. Because I could teach you that FET or field effect transistor is a type of the transistor which uses what? Electric field to control what? The flow of current. But unfortunately, you don't know the meanings of electric field. So now, if I have drawn the electric field, what the meanings of electric field? You fail to define electron. Try to define electric field. For we who have gone through advanced education, electric field is a vector quantity, it's not a scalar quantity. So electric field is the formula to compute electric field, is the symbol for a vector quantity, is equal to quantity of charge times permittivity of what? Of free space over what? Over square of the distance between the source of the charges. But this is not a vector quantity. So you can have U to indicate the vector quantity. If you want to find the magnitude of electric field, this is equal to quantity of charge times permittivity of the free space over square of the distance. Nyamegi stand up? Or sometimes we say that the electric field is equal to the electrostatic force over quantity of charge. So whether you use this mathematical formula, you can compute the electric field, or use this mathematical formula, you can compute the electric field with its direction. So this is vector quantity has magnitude and direction. Nyamege says standard. This is scalar quantity. So this one also, we have also to find the absolute value. And this is also what is scalar quantity. So electric field is equal to what? Electrostatic force. If you want to write out the vector quantity, we say that electric field is equal to electrostatic force, which is vector quantity over quantity of charge. So I know for all the diploma students, these are the new stories for you. And possibly might find that you might not say, electronics is difficult. No. Those are the simple mathematical questions. Okay? Don't go say yourself. I'm trying to build in your mindset something called the electric key. So whenever you mention field effect transistor, you have in your mind, it uses electric field to control what? To control what? That is the contents of one of the modules called the basic electronics. It's not the contents of my module. Right? But I'm not sure if you have been taught or you have not been taught. But I have to remind you, not just to draw the schematic symbol while you don't have an idea. Okay, class? Okay, class? Yes, for we who have gone through advanced physics, we have enjoyed this stuff. For you who have never gone through advanced physics, then we introduce to you the story behind. Do you like, so ask your neighbor, do you like those mathematical questions? Huh? Ask your neighbor seriously. Huh? Jacqueline, do you like this stuff? Huh? Show your neighbor how do you like them. Okay. So then, let me introduce you about types of 40 of field effect transistor. So he said that in electronics engineering, we have two types of field effect transistor. Namely, stop writing, look on the blackboard. The first one, this will be 221. We call it junction. This is fundamental electronics. Don't think that it's advanced electronics. This is fundamental. We call it vowels in language. A, E, I, O, U. A, E, I, O? Yes, of electronics. So don't think that, oh, you know that whatever this advanced stuff from where? These are fundamental. You still have a long journey to go. So it's called, say, junction field effect transistor. A? Again. A, again. Again. Examine your neighbor if he or she is pronouncing this first type of bipolar junction transistor. Say junction field effect transistor.
Junction field effect transistor.
Simply, or in short, we call it J-FET. So that's the name of your another child. Right? J-FET Kamanzi. J-FET what? Kamanzi. So two. Then the second type, we have metal oxide. Say metal oxide.
Metal oxide.
Say metal oxide.
Metal oxide.
Metal oxide semiconductor field effect transistor. This is the beauty. Tell your neighbor electronics is beautiful. Again, tell your neighbor whether he or she likes or she doesn't like. Tell your neighbor electronics is beautiful. Especially if you understand. If you don't understand, it's bitter. Can I clean this part? No. So finish to copy. So there's a difference between junction field effect transistor and MOSFET. I don't define them because it's not part of this lesson. But now let us focus on types. Types of what? Junction field effect transistor. Okay? Yeah? Hi. So in electronics engineering, I know that today you are getting surprised. We have two types of 40 of junction field effect transistor. Namely, the first one we call it and what are you discussing? N channel. So the first one we call N channel junction field effect transistor. The second one we call it P channel junction field transistor. Hey! Mention them. Say N channel JFET. P channel JFET. That's the name of who? Your child number? 410. For Kamanzi. For Kamanzi is approaching. For Brian is approaching good. Almost 12. Okay, fine. Don't worry about the number of children. Because if your father and mother say that 2 are enough, maybe I and you are not born. Okay. So now let us go straight forward. The schematic symbol. The schematic symbol of N channel JFET is this one. or so when you understand this class of schematic symbol, you may go and refer your 10 schematic circuit diagram to analyze whether you have understood what you've been drawing or you've been just drawing. Because I know in one of your schematic circuit diagrams, you found MOSFET or you found JFET, but by that time you didn't have any idea. You just drew as how you have found. Okay, stop writing. Stop writing, stop drawing. So this is the schematic symbol, either this one or this one. So listen. Listen. The JFET transistor has 3 terminals. Has 3, just like a bipolar junction transistor. However, that it allowed the flow of electric current by using only one current carrier. For the N-channel junction filled transistor, the majority carriers or the current carriers are electrons. For this one, the current carriers are what? Holes. Okay? Simple idea. So remember, in bipolar junction transistor, the central terminal in the schematic circuit diagram we call the base. So for the junction filled transistor, the corresponding terminal of base is called the gate. Say gate. Yes. Gardner is wrong. Then, against in the bipolar junction transistor, we have a terminal we call it collector. For the junction filled effect transistor, we call it drain. So this is the drain terminal and this is the drain terminal. For the bipolar junction transistor, whether NPN or PNP, we had a terminal that we call the emitter. In case of junction filled transistor, we have a terminal we call it source. Say get. Say get. Drain. Drain. Source. 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 Yes. So this is figure what? Faustina. A. Figure number what? Faustina. Eh? Brian? 17. Schematic symbol of N-channel junction filled effect transistor. So this arrow indicates the directions of current. Where? This arrow indicates directions of 40 current. This one and this one. So the current enters through the gate. G, let me help you because I love you so much. So let me help you to write the meanings of these letters. G stands for what? Yes. This is name number what of your child? Drain. So you may call one of your child drain. Right? A. And then S is standing for what? Source. Say source. Yes. Okay. The schematic symbol. Symbol of P channel. Say P channel.
P channel.
Again.
P channel.
The schematic symbol of P channel junction filled effect transistor is this one. So this is the schematic symbol. Simple for you to draw once you have the schematic symbol of 40. So this is gate, this is drain, this is source. Or you can draw this schematic symbol this way. This is gate, this is drain, this is source. Okay, class? Okay? Then we have types of MOSFET. Say types of MOSFET. Types of MOSFET. What the long term of MOSFET? Metal. Again. Again. Ask your neighbor, are you sure? So in electronics engineering, there are only two types of 40 of MOSFET. There are two types of 40 of MOSFET. So the first type, of MOSFET is called the depletion. Depletion. Have depletion. We call it depletion. Depletion mode. MOSFET. Say depletion mode MOSFET. And the second one we call it enhancement. Enhancement mode MOSFET. So say depletion mode MOSFET. Enhancement mode MOSFET. Again. So in case of the depletion mode MOSFET and enhancement mode MOSFET, we don't have the issue of P channel and the N channel. Okay? And there's a difference between depletion mode MOSFET and enhancement mode MOSFET. I don't want to touch it. Right? But just I want to teach you the schematic is in. So you can understand different schematic circuit diagram in electronics. So in depletion mode MOSFET, we have also two types. We have P channel or we have N channel depletion mode MOSFET and the P channel depletion mode MOSFET. So here we have N channel, so as I said, in depletion mode MOSFET, we have N channel depletion mode MOSFET and P channel depletion mode what? You have to understand the difference between them because these are fastest electronics switching devices. So schematic symbol of N channel depletion mode MOSFET is this one. Stop drawing and stop writing. Look here. So this is N channel. I said stop drawing, look on the blackboard what I'm drawing. These are confusing concepts in electronics more than you think. You might take them simple, but later on you'll understand what I'm trying to build in your mind. Okay? So, listen. These are in MOSFET also we have gate terminal, say gate terminal, drain terminal, source terminal. Okay? This is gate terminal, say gate terminal, drain terminal, say source mode. Or source terminal, excuse me, source terminal. Okay? So this is what we call N-channel depletion mode MOSFET. Are we together? It's quite different from N-channel junction field effective transistor. And I want to tell you that these are the electronics devices used worldwide to manufacture integrated circuits. Okay? Okay, so one of the key concepts that you have been missing when you've been drawing your 10 schematic circuit diagrams, the knowledge of symbols. Okay? So that's why that I expecting, or I used to fail to understand what you've been drawing. So this is figure what? Figure number what? Omari? Omari is not in the class. The schematic symbol 40. A. N. Channel. Depletion. Mode. MOSFET. We have just to cover depletion and enhancement mode. Then it will be the end of the class. So we are about to end our class because if I continue furthermore, you'll be confused rather than understanding. The schematic symbol of what? Enhancement of what? P channel depletion mode MOSFET is this one. Keep quiet, please. It's time to learn new concepts about semiconductor devices. Or So this is what? Gate terminal. This is what? Drain terminal. This is source. This is gate terminal. This is drain terminal. This is source. So do you see the difference? Hey! Do you see the difference between the N channel and P channel? Huh? What the difference? Direction of who? Arrow. Direction of what? Arrow. Directions of current or directions of volt. These directions of current. So for the P channels, always the current flowing outside of what? Transistor. For the N channel, always current flowing towards what? What? Remember that you'll be finding these symbols in a complicated schematic circuit diagram. You might find either this one or this one or this one with some other schematic symbols. So to interpret them, it's not simple the way you think. You might think that it's simple because you are learning it individually. But when you encounter them in the complicated or in the medium schematic circuit diagram, then you will be suffocating. So this is figure what? Gilead. Schematic symbol 40. Schematic symbol of 40. P channel what? How? Pardon? Figure 20, figure 19. Anyway, you should not bother about the number of figures. You may write yours. But according to our sequence, I think this have been told 18, this is 19. Okay, so now it's a time for enhancement mode MOSFET. Let us cover that concept and then we end the class. Enhancement mode MOSFET. There are two types of 40. Okay, just make some jokes. Enhancement mode MOSFET. Namely N channel enhancement mode. Enhancement mode and P channel enhancement mode. So this is the schematic symbol of enhancement mode or N channel enhancement mode MOSFET. Stop drawing. Stop drawing. Stop writing. Look on the blackboard. So the difference between depletion modes and the schematic symbol is this one. Where? So this is the difference. Filippo. And this is another difference. You. That is junction field voltage. That boy is junction field effect transistor, J effect. J effect was Lambert. AKA Christian. So do you see? That is the schematic symbol 40. N channel, not enhancement. N, say N channel enhancement MOSFET. Again. Again. So do you see the minor difference? Ah, okay. Then you say yes, but one day you will say no. This is enhancement or this is depletion. This is enhancement or this is depletion. So this is the difference. So here we have 3 bars, but for the depletion modes we just have 1 line. Are we together? Do you see how we cover the materials? Huh? Is the electronics beautiful? Huh? Yeah, okay. You are not sure. You are not sure because you don't know the next story after this. Eh? But the next story is good rather than this. So the schematic symbol of P channel enhancement mode MOSFET. Look again on the blackboard. Hey! So this is the schematic symbol. You have to examine the drawings of your neighbor because your neighbor now is careless in drawing because you're about to finish the class. So he or she is just drawing just to complete the class. And you have to examine your neighbor. Sometimes he or she is taking photos. You're taking what? With the belief that I will write them, draw them later. While in life there is no later time. And then for this one, so do you see? Do you see the difference? Here? Here? Yes. Okay. One day you will deny me that this is not enhancement. This is not P channel enhancement. Say P channel enhancement mode MOSFET. Do you look at your neighbor? Do you see your neighbors? What are they doing? Do you see Omari? Class A P channel enhancement mode MOSFET. Again.